My name is Varun Dad. I'm a faculty in the School of Computing and Electrical Engineering at Indian Institute of Technology, Mandi. In this lecture series, we are going to look at more advanced versions and commands of Git. So let's get started. As we have been explaining in the prior lecture, Git is actually a version control system. It allows us to keep track of the different versions of files in large projects, and it also allows us to go back to files which we may have and code which we may have changed or created in the past. So in general, in this lecture we are going to look at more in-depth look into Git and how it operates. So there are three concepts in Git related to modify, staged and committed. So as you can see in this diagram, there is a working directory which we had already created in the last lecture. There's a staging area, and then this is the Git repository, which is actually the repository where we have actually the Git deployed. So the idea is that the main thing to remember in Git is that if you want the rest of your learning to process to go smoothly, that there are three basically stages or states in which Git operates. One is committed, the other is modified, and the third is staged. So committed means that the data is safely stored in your local database, which is on your local machine. Modified means that you have changed the file on your local system, but you have not yet committed it to your database. That is the Git repository, the Git database. And if it has not been committed yet to the database. And staged means that you have marked a modified file in its current version to go into your next commit snapshot. So modified basically means, staged basically means that we are already modified a file and we have staged it to be committed whenever the next commit is made. So basically, as you can see, we basically check out a project from the directory, which is the local database, into the working directory. We stage fixes, we may make some changes and we stage them, and then we make them committed into the local repository. So this is the process through which Git operates. And the Git directory is the database, the working directory is where we work in the files, and the staging area is another intermediate stage where we stage the files for being committed. So the Git directory is where basically the Git stores the metadata and object database of your project. And this is of course the most important part of the Git, as it is what is copied when you clone a repository from another computer. The working directory, like we had run the git clone command in the last lecture, and we had cloned a repository on our local computer. The working directory is a single checkout of one version of the project. These files are pulled out to the out of the compressed database in Git directory and placed on the disk for you to use or modify. The staging area is a file which is generally contained in your Git directory that stores information about what will go into your next commit when you make the commit. It is sometimes referred to as the index, but it is also common to refer to as the staging area. Now, the basic Git workflow is the following. You modify files in your working directory, then you stage the files, adding snapshots of them into your staging area, and then we do a commit which takes the files as they are in the staging area and stores that snapshot permanently into your Git directory, which is on your local machine. So if a particular version of a file is in the Git directory, it is considered committed. If it had been modified and was added to the staging area, it is staged but not yet committed. And if it was changed since it was checked out but has not been staged, it is in modified state. So basically these are the kind of three stages through which the files can exist in a Git repository. So I'm going to tell you how to install Git. This is something which we have already seen in the last lecture, but you need to run on a Linux system which has a Fedora based Linux, this kind of command. And for a Debian based distribution like Ubuntu, which we had seen, to install Git, if it's already not there, you're encouraged to run apt-get install git command. And generally there is also a set of codes available for installing it on a Mac and installing it on a window, which you can refer to here, and get the Git installed on these operating systems as well. So that way, Git operates on a large majority of operating systems available in the real world. So now the question is that once we have installed Git, we should first, what we should do is to set up our username and email address. And generally you can do this because why is it important to do this? Is because every Git commit will use this information as to who committed and what was their contact information. And this is important to understand who is working on what part of the code and what is being committed, even to a global repository later on from the local repository. So git config --global user.name, and you can define the username, and git config --global user.email email address will allow you to create a username and email address for your Git repository. Last lecture we already did this. If you have not seen it, please watch it. So you also need to set up your editor in Git. If you want to set up say Emacs editor, you can set up git config --global4.editor Emacs, and on Windows you may set up some editor like Notepad++, where you give the path, and similarly on an x64 64-bit system you may do a path to the 64-bit. In this case we are giving it the 86-bit the 32-bit version x86. This basically are giving the path to the executable of the editor. You also need the editor because whenever you commit, you may have to write something, a line or two, as to what is in the commit, what are you trying to commit. So those remarks are actually mentioned in the editor. So for example, if you want to check your settings, you can get the git config list command, which we had already run in the last lecture, and you can see it will list out all the different defaults which have been set. You may see keys more than once because Git reads the same keys from different files. In this case, Git uses the last value of unique key it sees. And you can also check what Git thinks a specific key's value it by typing git config key. So for example, git config user.name will just display user.name. And by the way, you can also refer to help in Git, where there are 3 ways to get the man pages or the manual page for Git. One is to git help verb, git verb help, and man git verb. So for example, if you want to read about the config command, you can write git help config. So now, before we set up any repository, we need to initialize the repository in the existing directory. So once you have cloned the repository, you need to initialize the repository, which will basically start tracking the repository. So what we need to do is, we need to go to the projects directory where we have cloned, and we need to run git init command. This creates a new subdirectory with a .git that contains all the necessary repository files, a git repository skeleton. At this point, nothing in your project is tracked. The git internals for more information. So at this point, nothing is tracked, but it's like initialization of and telling it that we are going to track files in this folder. And then of course you can run the git clone. You can of course clone a repository, which we have already seen in the last lecture, where you can write git clone and the name of the repository, and this will create a directory called libgit2, initializes a .git directory inside it, pulls down all the data from that repository, and checks out a working copy in the latest folder. So if you go on to new libgit2 directory, you can see the project files in there ready to be worked or used. If you want to clone the repository into a directory named something like libgit2, you can specify that the next command line option by this way. So the idea is that there is a global repository, and git clone will clone the repository on your local machine. But git clone is a very powerful command. What it does, it not only clones the global repository, it also creates a directory by that same name. It also checks out a working copy of the latest version into a working state or working directory. So basically a working copy is also checked out. And if you wanted to name something else like your local repository, not libgit2, you can write this name and this will be the name of your repository when it is cloned. So now there are other ways of doing commands, particularly one is git commit and the different file states, which is an important command because once you have worked on a file which is modified and you stage it, you want to commit it. So you want to start version control existing. Yeah, you should probably begin tracking those files and do an initial commit. You can accomplish this with the git add command that specifies the file you want to track, followed by the git commit. So if you say git add star.c, it will track all the .c files, and then you can also add a license file. And then when you say git commit -m initial project version, this is the command, and this is basically the message part, and this will commit all the files which are being tracked. So, so basically the idea is, so at this point in time, you have a Git repository which has tracked files and an initial commit. So generally, it's always good to do git clone and then git commit, add the files to be tracked, and then basically commit them, which is the initial commit. So remember that each file in your working directory can be in one of the two states, which can be tracked or untracked. Remember, if that file is untracked, Git will not be able to track different versions of it. So as to be able to track it, we need to add it to the Git repository using the cat. Tracked files are the files that were the last snapshot, were in the last snapshot. They can be unmodified, they can be modified, or they can be staged. Untracked files are everything else, and these files in your working directories that were not in your last snapshot and are not in your stage integer. When you first clone a repository, always remember all your files will be tracked and unmodified because Git just check them out and you haven't done any editing. So that's the power of git clone. It will track all the files which are checked out or downloaded from the internet, say from the GitHub page. As you edit the files, Git seems to sees them as modified, and because you have changed them since your last commit, that's why they are modified. You stage these modified files and the commit all your state changes and the cycle repeats. So typically you have some untracked files, you can add them and you can stage these files. You can edit these files, they become modified. You can again stage these files. You can also remove some files from the state unmodified, which will become untracked. And then you can of course commit them, which will bring them into an unmodified state. So the main tool you use to determine which files are in which state is the git status command. And if you run this command directly after a clone, you should see something like this, that git status on branch master. So master is the default branch which you are tracking, and your branch is up to date with original master, nothing to commit, working directory is clean. So idea is get status tells us about all the status of different files in your Git repository. Let's say you want you add a new file to your project. A simple readme file can be added. If the file didn't exist before, you can run git status and you can see untracked file and so on. So for example, in this case, I have echoed my project into a file called readme. This is redirection. So I've created a file called readme, and then I have with this particular two words, and then I am doing git status. So see, I have modified the readme file. So your branch is up to date with master. Untracked files to include in what will be committed is this. So the idea is this is a newly created file. It is still untracked, and it is telling me that you need to add this file to the Git repository if you want it to be tracked by Git. So the next thing is to track this file, and in order to track the new file, you basically will run git add. So it will basically git add will add the file into the tracking, and then when you run this, you will say that your branch is up to date, and then you need to basically if you want to unstage a file, means untrack a file, in that case, or not be part of the commit, then you need to run git reset head file name, and the new file is this. So let's change a file that was already tracked. If you change the previously tracked file called contributing.md and then run your git status command, you get something that looks like this. So if you already change the file that was being tracked, you can actually see it tells me that new file changes to be committed is already in the staged area, and changes not staged for commit are basically the contribute.md, which it is actually saying that you can either add it to the staging area by doing git add, or you can git checkout and the name of the file to discard the changes in the working directory. So all the changes you have done will be discarded, and the older version of the contribute.md will be overwritten on top of it. So git status -s command will actually give you some more status, like for example, it will start giving these markers, and generally these files which are with the double question mark untracked have a this to them. New files that have been added to the staging area have an A to them, and modified files have an M to them. And these are two columns in the output. The left hand column indicates the status of the staging area, and the right hand column indicates the status of the working tree. Okay. And one more thing is that, so for example, in that output, the readme file is modified, as you can see, in the working directory, but not yet staged. While the simple git.rb file in the lib folder is modified and staged. Okay, the rake file, so the idea is that the rake file was modified and staged and then modified again, therefore it is a double M. And so there are changes to it that are both staged and unstaged. So probably I would like to stage the add file again by running a git add command. So the idea is that there are two columns of the output. The left hand column indicates the status of the staging area, and the right hand column indicates the status of the working tree. So this is basically the important points in the two things. And ignoring the files, if you have a class of files that you don't want Git to automatically add or even show you at the beginning of the untracked, these can generally be automatically generated. Generally these are log files and things. So we can actually create a file listing called git.gitignore and cat it, and then we can write a regular expression like we do not want to see any of the files which have a .o or .a in it, so it will not show anything like that. The first line tells Git to ignore the files with .o and .a objects archives that may be in the product of building your code. These are intermediate files. As we have seen, .o files are typically created object files during C compilation process or CPP compilation process. The second line tells Git to ignore all the files whose name end with a tilde. This is another rule which is used by many text editors as Emacs to mark temporary files. This ends the lecture on Git. Particularly, we have learned about Git basics, the different stages of a file, which include modified, stage, and commit. I would like to acknowledge my TAs who have helped me create this lecture, and you can also go to the Git SCN page to see the material which is being taught. This is the source of the material. Now we come into the activity, and the activity in this particular lecture is to try out the things which we have covered in this lecture. So basically, first, if you have cloned already a repository, you can determine which files are untracked and tracked states. You can do so by running the git status command. Now you can actually change, say, the factorial.cpp file to include a check for the factorial for negative number. So if there is a negative number entered, the user is asked to re-enter a positive number. So now this factorial.cpp becomes a modified file. And once you complete step 3, we can again determine the state of the file, and you will see it will be shown as modified. And then in order to begin tracking and staging above, you may want to do the git add followed by a status check again. And if you want to ignore that you really don't want, you can always write that .gitignore file. And we can also use, we will look at this diff to view the differences between your staged and unstaged file as part of the future lecture. Thank you so much.